in terms of engineering research, if you're dealing with, let's say, the streamlining effects around a car or a lift on an aerofoil or something like that, you're probably going to want to test it in air. And you do that using a device like this, which is a wind tunnel. And basically, a wind tunnel is a device for blowing air across an object. And that goes on to something. What we've got here is a large fan here, which draws air in from the lab over here, goes through a chamber here called the working section and out the back. This is a straight through wind tunnel, and what we would do is place a scale model of whatever we want to test in the working section. This is a typical example. This was a third-year project some years ago. It's a Lamborghini sports car. Now, I have to admit to you, they wouldn't sell many sports cars if they looked like that. I'm well aware of that. But let's face it, Lamborghini can throw 10 engineers at this for 10 years. I had one student working on it for 3 months. So we had to make it a bit simpler. So what this is the student designed in CAD a generic sports car, used Mike's rapid prototyping machines to create the shell, filled it with plaster of Paris, added the wheels, sanded it down and painted it to give a model. You'll see there's a hole there which was attached to a force balance, placed into the wind tunnel, and the student was able to measure drag forces on this and to look at the airflows around it. And that's very typical of what engineers do. The student also did some computational fluid dynamics, same geometry put into a CFD package, do the calculations to look at the airflows around the car and compare the two results. I'm going to read this up, which is our other main tunnel. Let's gather around. I promise you I won't shock anybody by blowing air at you. What we've got here is, that's a smoke generator. What we have here is what's called a recirculating wind tunnel. You're actually only seeing half of it. The rest is underneath. Don't worry, I've got everything under control. The rest is underneath because there are 2 large fans underneath there, underneath the floor here, and they blow air around in a circle, so it comes up that end, blows through this, which is the working section, and off down in that direction. Now,
it doesn't work.
Don't worry, I have set fire to the lab once, but that's not what's happening. Close that, you can see there's a model of a wing section there. And if I press go on this is going to blow air across here. You can see there's quite a wind going on there. One of the things we can do, that's connected to a lift drag balance and has an output here in terms of lift and drag forces. The other thing we can do is with this is what's called a smoke wand. It's basically a heated element at the end, which I'm going to turn down a little bit, which is it's pumping oil into the tip there, and the oil is burning to produce the smoke. Now, like this, you can just see circular vortices and a few extra bits there. What I can do now is put this smoke into the wind tunnel like this, and investigate. And I can actually see, I don't know if you can come around a bit further and see this, you can actually use this to mark where the airflow is going, and from that understand the flow of air around the wing. If I adjust the angle of attack a bit, like that, we can actually see different flow patterns as a result of that. Now, I can't do this too long because it's a recirculating wind tunnel, and eventually it's going to fill up with smoke. So instead, I'm going to put this out here and fill your lungs up with smoke instead. But that's illustrative of the sorts of things you can do with a wind tunnel, the sorts of things which we tend to do with our undergraduate students as part of the course. Right, there we go. Any questions?